My name is Bob Downing. I work for the Wisconsin Department of Transportation as an engineering specialist, and today I'm going to be showing you the Atterberg limits. The Atterberg limits are a basic measure of boundaries between the different states of a soil, and we accomplish this by determining the water content of each one of these boundaries. Now, the equipment that we'll need is, of course, our sample that we prepared with T146. All this is P40 material. We are going to need our spatulas for mixing the soil. We also need a limit device determining the liquid limit. We need a gauge block for calibrating this liquid limit device. We also need masking tape for calibrating, and we also need a frosted plate to determine the plastic limit, and we need containers for determining the moisture content, and we also need distilled water. Prefer to use distilled water because the procedure says you need to do some comparison testing in order to use tap water, and it's just easier to go spend $1 on some distilled water. Now we're going to be determining these boundaries between the different states of soil. Now, the different states of soil for this particular test, we have a solid, we have a semi-solid, and we have a plastic, and then we have a liquid. Now, this material right here, we'll start with a solid. This has been dried off in a 60-degree oven. It has little or no moisture. Perhaps we have some hygroscopic moisture in it, but since it's a solid, the loss of any further moisture won't change the volume of this soil. Now, what I'm going to be doing is I'm going to be adding this distilled water, and I'm going to get it into a semi-solid state. It'll still be crumbly, but you'll see some cohesion to it, but it won't be plastic. Now, but if I remove any of the moisture, it will change the volume. The material will shrink in a semi-solid state. Now, what I'm going to be doing after that is I'm going to be mixing more water into it with the spatula and distilled water, and I'm going to get it to its plastic state. That means it'll have cohesion to it, pretty good cohesion to it, and it will hold its shape. Now, according to the Atterberg limit test, if I can roll this out into an 1/8-inch thread or a 3-millimeter thread on this frosted glass plate, it's considered plastic. Now, what I'm going to do is I'm going to take an 8-gram ball and roll that out, take about 2 or 3 grams of that 8-gram ball at a time and roll that out and crunch it back up together again, and roll that out into an 1/8 of an inch thread, and crunch it back together, roll it out, and keep doing this process until this thread breaks. At that breaking point, I'm going to be taking a moisture content. Now, that will be our plastic, the lower end of the plastic limit. That will be when the material turns into a plastic, into a semi-solid state. Now, since I have the sample, it's wet, I'm going to be adding more water to it and more water to it, mixing it and kneading it, and then I'm going to get this up into a liquid state. Now, the bottom of this liquid state, according to the Atterberg limits, is when I put some soil in the bottom of this liquid limit device, have this grooving tool, and make that into 2 pats of soil on the bottom of the liquid limit device. And then I turn this on, and I get 25 blows, and the soil comes together at 1/2 inch. That is when I take the moisture. That is the lower end of its liquid state, and that's called the liquid limit. Now, we have the plastic limit that I described earlier, and I have the liquid limit. Now, the PI, the plasticity index, is the liquid limit, which has a higher moisture content, and the plastic limit, lower moisture content. If we subtract the plastic limit from the liquid limit, that will give us the PI, or the plasticity index, excuse me. So that is the actual range where the soil can be in a plastic condition. So what I want to do before I start anything is make sure my liquid limit device has been calibrated. And the way we do this is we actually take this gauge block, which is 10 millimeters thick, and we actually want to make sure that the drop of this cup is 10 millimeters. So what we're looking at here is, see where this is worn, and this is worn on this plastic base. That's where it's hitting. So what we want to do is we want to bisect this worn circle. With the masking tape. I'm going to tape this halfway. All right. Now what I want to do is I want to take this and actually push against the masking tape. Therefore, this gauge block, which is approximately 10 millimeters thick, we can adjust the height by turning these screws, these set screws, and this adjusting screw back. I'm going to turn this on and see if this is adjusted. Nope. What we want to do. Now, when we hear a click like that, yeah, there it is. This is actually adjusted. We just hear that tick. This cam is barely hitting this, and we can barely hear this ticking. So this particular machine is an adjustment. What I can do is I can pull this out of adjustment just to show you how we calibrate it. I move that adjustment screw, put the set screws down, make sure that's down, push my gauge block against the tape to make sure that mark underneath has been bisected, and I'll turn it on. Now, according to this, we can see movement, and this is too high, so the drops are if I were to put soil in this, the drops would be putting too much energy into the soil, and then it would prematurely close. So what I want to do is take the set screws off and readjust this. Put the set screws back on. Okay, now I can't hear it at all, and that was a little too far. Pull this a little towards me. Readjust the masking tape. Make sure my set screws are set. Make sure I got the tape right. Still see some movement. Just a little more. Make sure that's down. Just the tape. Okay, make sure that's on the tape. Okay, I can barely hear it ticking. Make sure that's at the tape. Okay, this is what we're looking for. It's against the tape, and it's barely snapping. It's barely moving. You can kind of feel it vibrating. And now this is an adjustment. Okay, we're going to turn that off. Make sure we remove our tape. The set screws are set. The liquid limit device cup is down on its base. Now we have our liquid limit device calibrated. It's time to mix up the sample. So what I'm going to do is take some of this P40 material, approximately 100 grams, 110, 120 grams, because I'm going to be doing the 3-point method for the liquid limit. Now what that is I'm going to be adding a little moisture. I'm going to get this past its semi-solid state, and I'm going to be mixing this up into its plastic condition. I'm going to take one of these spatulas. I'm going to take the different one there and mixing up this soil. This spatula is nice and stiff. The bowl I'm using is non-porous. It's porcelain. All the glaze has been from this bowl has been scratched off. Gives us a nice rough surface. So I'm going to be mixing this, and then I'm going to, when I get this into its plastic condition, I'm going to be taking an 8-gram ball from this. And then I'm going to continue on adding water to this to bring to its liquid condition. Now we're looking for soil, 2 pats of soil at the bottom of the liquid limit device, that when I split them, they come together at 25 blows. However, that's pretty hard to get, to know enough of this soil to add water to get it exactly 25 blows. Now this 3-point method that I'm doing, first it's going to be dry. So what I'm looking for is when I put that in the liquid limit device, I'm going to be doing a three points. And the first point, if that pat comes together between 25 and 35 blows, take a moisture. And then what I'm going to do is I'm going to add a little bit more moisture to the sample, put a second pat of soil in the bottom of the liquid limit device, and what I'm looking for is a closure of a 1/2 inch on that particular sample between 20 and 30 blows. Then I'm going to take a moisture from that. Then after that, I'm going to add a little bit more water, and I'm going to be looking at a closure between 15 and 25 blows. So we have 3 ranges of 10, and each one of them overlaps. So according to that, all of our ranges have been satisfied. Remember, we need one between 25 and 35 blows. We need another point between 20 and 30 blows, and one more point between 15 and 25 blows. With that, we'll have a moisture content, and we'll also have blows, and I'm going to show you how to graph those out. And where that graph crosses 25, that is our liquid limit. Now, of course, I've added enough water here, and I know this is plastic, but I'll prove it. I'll take a little bit out of here, take my 8-gram ball, or a little pinch off from approximately an 8-gram ball. Let's see if I can roll this out to an eighth of an inch. So what I'm doing over here on this frosted glass plate is I'm rolling this out. I'm going between 80 to 90 strokes per minute, even pressure. I'm not pushing, and I'm rolling this out 80 to 90 strokes a minute, and I'm rolling in between the tips of my fingers and the middle of my palm. And I'm riding my heel as I'm rolling this out. And actually that helps me get even pressure. You can roll out like this. You can roll it out without using the heel of your palm, but I prefer to do that. So I was able to roll that out to an eighth of an inch. Remember, it has to be on the frosted glass plate, 80 to 90 strokes per minute, and even pressure. We can't take a pinch of this, say it's barely cohesive, we can't put it in the palm of our hand and barely roll it out. If that's the case, that's not part of the test. So it's got to be on this glass plate. I'm going to take this, put it back in, mix that up a little more. I like to get another ball out of here, mix that up, because all I was doing was proving that that is plastic. Now, I'm going to take another 8-gram ball out of here, set this in a bowl, and cover it. Set this aside and let that season. And I'm going to continue on with the liquid limit, now that I've proven that that's plastic. So we continue on with the test. If I wasn't able to roll that out, I would actually discontinue the test and call it non-plastic, or NP. So I'm going to keep adding water to this and bring it up to almost the liquid state. Well, this is pretty clayey soil. Add a little bit at a time. Keep cutting it and make sure I get an even mixture throughout this. And of course, this is going to be the first sample I'm going to put at the bottom of the liquid limit device. Has the least amount of water in it, so it'll take more blows to close it. A little more. What I'm looking for is a closure between 25 and 35. Okay, I'm ready to come around, and I'm going to be putting a pad of the soil in the bottom of the liquid limit device. I want to make sure that this is down. Our liquid limit device is set on 0. I'm going to take a pad of this soil, put it on the bottom of the liquid limit device in the cup. A little more. And what I'm doing with this this knife is I'm actually holding it level. I'm holding it level, and we don't want this to be more than 10 millimeters thick. So if I hold this knife level, that thickness will be 10 millimeters on the bottom of the bowl. So I want to use the center, actually want to use the center as a pivot point. I don't want to coat the bottom of it, change the weight of the bowl. I just want to have a level pat right there. Take my grooving tool. I like to do it in one sweep, but we're allowed up to 5 to actually split the soil. Okay, now it should look like this. Now we have the luxury of an electric motor in here, and this is going to thump at 2 beats per second. And we're going to look for a half inch closure. Okay, now it looks as though we have a half inch closure, and that's at 34. So now we've met that criteria between 25 and 35 blows. So what I want to do is take one of my watch glasses, containers that's been tared, cut out where it was actually closed, and take the moisture content of that particular sample right there. Now our scales we should be going to 2 decimal places. Now I'm going to scrape this out, add it to the initial sample, wipe everything off, make sure that's clean. We're not allowed to put any more moisture into this cup after we have mixed up the sample, and dry wipe this so we don't leave a residue on the bottom of the cup. All right, set that back to 0. The grooving tool aside, make sure our sample blade is clean. And on to the next point. Add a little bit more water. Mix up. Now our next point, we're going to be looking for a half inch closure between 20 and 30. Make sure this is mixed. Okay. This goes a little better, a little easier. Start out in the middle of the bowl of the cup. A little more. And one thing we have to do is we have to cover the sample as we're actually running the test. Set that aside. Make sure that's nice and level. Use the center as a pivot point. Grooving tool, one swipe down the middle, and make sure you don't touch the machine as this is running. It's going to run again 2 beats per second, and here we go. Okay, that is closed at least 1/2 inch. It's better. I'm going to take note that this is 25, and it's better to go beyond 1/2 inch than it is to start and stop. Once this machine is stopped, that's the end of that particular run. So we actually went 1 beyond. So this is 25. I'm going to call this at 24. You take a moisture content. And weigh these right away. I'm only setting these aside because I don't have an oven quite handy right here. So and scrape this out. Put everything back in. Make sure this is clean. Clean this out. Clean the sample knife off and dry wipe everything. That's to not leave that residue again. Make sure this is down. Set this to 0. And then continue on. Add more water. And to wipe this grooving tool off. Add more water. And next we are looking for a point between 15 and 25. All right, now we've added more water to the sample. We mix that up. And now we're looking for a closure between 15 and 25 blows for the soil to close up a 1/2 inch in that range. I'm going to take a pat, cover up my sample, start in the middle, make sure that's level. Okay. All right, and now the pat should be flat. That's set at 0. I'm going to take my grooving tool. Sure, that's nice and dry. Make one pad into 2. And turn on the machine. Okay, now we have a closure at 18, at a 1/2 inch at 18. A good way to measure, I usually eye that in, just memorize what a 1/2 inch is. However, we can actually, the end of the grooving tool is 13 millimeters, which is a 1/2 inch. We can actually compare this portion of the grooving tool, I'll point to that, from that tip to that tip should be 13 millimeters. And then I can actually put that into the soil and make a mark, and that will be our 1/2 inch that we're looking for. That closed 1/2 inch at 18. I want to cut this out. Take this sample, and we're going to take a moisture there. Of course, we have recorded all of this. We had 34 blows, 24 blows, and now 18 drops of the liquid limit device. And we'll get moistures at all 3 of those points, and that will give us a nice graph. Now that we're finished with the liquid limit, we'll continue on with the plastic limit. The 8-gram ball that I previously took out from the sample and set aside and season, well, we'll bring that back into the picture. Now we have this 8-gram ball, and it's still nice and moist. What I want to do with this is I want to pinch off about between 2 and 3 grams. And I've already proven that this is plastic material. Now I want to continue on with this plastic limit test. Remember, rolling this out into an 1/8 inch thread. And putting it back together. until it breaks. Kind of rolls off there. I'm doing between 80 and 90 strokes per minute. And I'm taking the same between 2 and 3 gram sample and crumpling it back up and rolling it again. It's getting a little drier. Roll that back up. A little moisture. Take the moisture out. Now this, when we're doing this test, it requires this plate to be frosted because it will extract more moisture from the sample other than like a smooth glass plate. And keep rolling this out. Starting to break up in shorter and shorter pieces. And we just need to keep rolling it out into 1/8 of an inch thread. And when that breaks, I'm going to be putting it in my moisture container there, my little watch glass. Make sure those go all the way down to 1/8 of an inch. Breaking and breaking. Now, while I'm doing this, I don't want to add any pressure to this. Twist my fingers or lighten up on pressure just to make this, just to make it break and shorten the test. That wouldn't be the accuracy that we want. Okay. Now we're looking for it to either flake or entirely break down, or it to make barrels. A 1/4 of an inch. And then that actually broke down pretty quick once enough moisture left the sample. And this is what we're looking for. Okay, now I'm going to take that, pinch it together. There's still some plasticity to it, but according to AASHTO, the Atterberg limits, according to the procedure, if that can't be rolled out to 1/8 of an inch, or 3 millimeters, that is in its non-plastic state right now. So I'm going to take one more piece of this, roll it out, and I'm going to do the same thing. I'm going to roll it out. Okay. Crumple it back together. Make sure I don't push down to make it smear. Even pressure. It's also allowed, you can pinch it around in order to take moisture out of it. So make sure that gets rolled out. to 3 mils or 1/8. Now the more plastic, the more clay content of these, the harder it is to roll out. That means the more pressure, not the harder it is to roll out. It takes a little bit more pressure, but even pressure with higher clay content. And we need a little bit more pressure, of course, as the moisture goes down in these samples, or moisture is extracted from the sample. Almost there. Getting pretty dry. Let's see here, it's getting pretty dry. Now, those are a little long right now. I would say one more time, and that'll do it. Yep. There. That's kind of, it's all breaking up. That's what we're looking for. Again, it looks just like the last one. We take that, these, and make sure we cover that, not to lose any more moisture out of it. Then we take our last piece, some from the last one, anyway, and now we roll this last piece out. So each of them were about 3 grams, between 2 and 3 grams. Oh. And remember, this is going to be the bottom end of the plastic range of the soil, which is the plastic limit when it turns in from a plastic to a semi-solid state. The 3/8 inch barrels, if this breaks off at 3/8 of an inch, not a quarter, then that's the end of the test too, or if it just breaks down completely. I'm having to use a little bit more pressure to roll these out. It's getting close. I think it's about there. Crumple it up, and I think it's one more time should do it. And then after that, yep, it just breaks down completely. Once it loses its moisture, or most of its cohesiveness, or the moisture holding it together, it'll break down pretty quick. So here we are, the entire 8 gram sample, which doesn't weigh 8 grams anymore because it's lost some of its moisture. Get all these little pieces in there as much as we possibly can, and put this in the watch glass is what the particular sample container that I have. However, you can also use one of these for any of the moisture points, the liquid limit or the plastic limit. So most people have these little tins. So there we are. We take the moisture of that, and that will be our plastic limit.